Welcome to Session 5. In the last lesson, one crossing gave us 4 angles. Now, we're going to combine 2 ideas, parallel lines and a single line that crosses both of them. That crossing line has a special name. It's called a transversal. When a transversal cuts across 2 parallel lines, it creates 8 angles all at once. And those 8 angles have wonderful, predictable relationships. The best part? You only need to learn 3 simple rules to find every single one. Here are 2 parallel lines. Notice the matching arrow marks on them. Those arrows are the signal that tells us the lines are parallel. Now a transversal slices across both of them. Let's count the angles it creates. 4 at the top intersection, and 4 at the bottom. 8 in all. Here's the amazing thing. Every one of those 8 angles is either equal to the angle you start with, or supplementary to it. So there are really only 2 different values in the whole picture. Our 3 rules will tell us which is which. The first rule is corresponding angles. Corresponding angles sit in the same position at each intersection. For example, the upper right corner at the top crossing and the upper right corner at the bottom crossing. When the lines are parallel, corresponding angles are equal. Here's a way to see why. Imagine picking up the top intersection and sliding it straight down onto the bottom one. Because the lines are parallel, everything lines up perfectly, and the matching angles land right on top of each other. The second rule is alternate interior angles. The word interior means these angles live between the 2 parallel lines, in the middle region. The word alternate means they're on opposite sides of the transversal. When the lines are parallel, alternate interior angles are also equal. If you trace from one angle to the other, they form a kind of Z shape across the figure. So, whenever you spot that Z, you found a pair of equal alternate interior angles. The third rule is co-interior angles, also called same-side interior angles. Like the last pair, these sit between the parallel lines, but this time on the same side of the transversal. And here's the key difference. Co-interior angles are not equal. Instead, they are supplementary. They add up to 180 degrees. Tracing between them forms a C shape, and that C is a handy reminder. C for co-interior, and the 2 angles combine to make 180. Let's put numbers on it and see how fast this goes. Suppose one of the angles is 110 degrees. Its corresponding angle, in the same position at the other crossing, is also 110. Its alternate interior partner, forming that Z shape, is 110 as well. And any co-interior or neighboring angle is 180 minus 110, which is 70. So every one of the 8 angles is either 110 degrees or 70 degrees, 2 values, filling the entire figure. That's the power of parallel lines. Here's a reliable, no memorization way to spot the pairs. At each intersection, picture 4 corners: upper left, upper right, lower left, and lower right. Corresponding angles occupy the same corner at both intersections. Alternate interior angles are between the lines on opposite sides of the transversal. Co-interior angles are between the lines on the same side. So you don't have to memorize a list of names. Just read the position, and the position tells you whether the angles are equal or supplementary. Let's see it in the real world. Picture a straight road crossing 2 parallel train tracks. The angle the road makes with the first track is exactly equal to the angle it makes with the second track. Those are corresponding angles, and they're equal precisely because the tracks run parallel. Surveyors, builders, and mapmakers use this fact all the time to transfer an angle from one line to another without measuring twice. Now the single most important warning in this lesson. All 3 of these shortcuts, corresponding, alternate, and co-interior, only work when the 2 lines are truly parallel. If the diagram does not state that the lines are parallel, or mark them with matching arrows, you cannot assume they are, no matter how parallel they might look to your eye. Remember, GED figures are not drawn to scale, so always hunt for those arrow marks first. No parallel marks means no shortcuts. Let's check your understanding. A transversal crosses 2 parallel lines, and one angle measures 110 degrees. What is its corresponding angle? Corresponding angles sit in the same position at each crossing, and when the lines are parallel, they are equal. So, the corresponding angle is also 110 degrees. Let's recap the three rules. Corresponding angles are equal. Alternate interior angles, the Z-shape, are equal. Co-interior, same-side interior angles, the C-shape, are supplementary, adding to 180. Read the position to choose the rule. And remember, all three hold only when the lines are marked parallel. Wonderful work on Session 5. Parallel line angles are a favorite on the GED, and now they're yours. You can transfer an angle across a whole figure with confidence. Next time, we shift gears from lines to shapes and start classifying triangles by their sides. See you there.